Hello everyone, welcome back to another session of the CAD Bootcamp. Today gonna be the last session of the Bootcamp this year, and in this session, session 9, I'm gonna go through the introduction to the computational fluid dynamics using SOLIDWORKS. In this session, we're going to talk about the basics of the computational fluid dynamics, the necessary processes that you have to do for CFD, and also we're going to practice the CFD using the SolidWorks Flow Simulation to see how we can conduct the CFD within the softwares of the SolidWorks. So you're familiar with this design process that I've talked about it earlier about the finite elements analysis. So whenever you have a design in mind, of course, you always start by having problem definitions, doing the brainstorming, come up with a few design concepts, and pick up the design you're looking to go forward. And then once you pick it up, you want to take it to the computer-aided design to be able to visualize it. And what you used to do, you used to actually go to the physical prototype in a stage to make a few physical prototypes to be able to do a testing. And based on the results you get, you're supposed to come back and redesign it and modify your design, and again, come back and make another prototype and test it. So that's basically infinite loop. Depends on what models, what kind of parts you're dealing with, the number of iterations and change in design would be different. But again, this method, first of all, is really time consuming. It's quite expensive because you have to make the prototype every single time. Whereas by using the computer-aided engineering, what you can do, you can use the software to be able to simulate those kind of conditions virtually, and then see the results and see whether you're happy with it or not, and come back and modify your design, amend your design, and of course, and again, go and run the simulations and see the results. Of course, once you're technically sure about what you're gonna do, you're gonna make a couple of prototypes to make sure it will be able to perform and the result you get is accurate. This method using the CAE is much more easier, is faster, is also cost efficient as well because you don't deal with the cost of the manufacturing. And in terms of basically talking about CFD, I can say that we live in the world of emotions. So all of our movements interact with the fluids. For instance, whenever you walk into the corridor, there's an airflow around us. And also the body, it has a heat. The heat goes toward the air. For instance, it goes toward the head, which then goes to the ceiling. So it always will interact with with some sort of fluids. For instance, if you're driving in the car, it's actually the airflow goes around the car. So every aspect of the change in our world, it's shaped by fluid dynamics. That's why we need to be able to predict and control these fluid dynamics, and CFD is one of the main tools for this aspect. Computational fluid dynamics, or in short forms, CFD, is a process of mathematically modeling a physical phenomenon which involves the fluid flow and try to solve it numerically using the computational power that we have. CFD is quite common, and in lots of industries such as the biomedical engineering, the automotive, aerospace, they use the CFD as it's a really useful and powerful tool to be able to see these interactions with the fluid around us. But once we talk about the CFD, we need to decide what kind of method of analysis we're going to go forward and use. We can go to the analytical, which basically we need to work with the mathematical equations to be able to understand those kind of interaction of between the fluid and the object that we have, which is, to be honest, quite tricky. It's not easy. We don't have any generalized equation for all cases. It's basically the equation for really simple cases. As you can see here, for instance, Navier-Stokes for just the box. And on this side, we have the experiments that basically is really accurate. It's really good. But again, on the other side, it's quite expensive because you need to have a high level equipment, which are expensive. You need to highly calibrate them to make sure the result you get is accurate as well. And it's basically time consuming, is also quite expensive. And in between, you have the computational one, which basically is using the analytical, the equation that we have, try to use to make our model to convert to the simple model to be able to apply those analytical ones, and try to replicate what we used to do in experiments using the software. And this one is much more cheaper, of course, because we're going to do it through the computer. Also, is as close as the accuracy of the experiments, depends on how you're going to run that. But as I mentioned earlier, we want to still apply those kind of equations. Let's say if you are working with a fluid and you're gonna have it as internal or external fluid, doesn't matter. What we want to do, we want to simplify that model, a geometry, to be able to apply these equations. For instance, the equations that you see here is basically represent the Navier-Stokes, and what it does, it actually is a formulation for a box, a simple box. So what I have to do, I have to convert my model, or let's say discretize it to the smaller cubes, 1,000 or millions of them, which we call it as cells, as a part of the mesh generation. So the mesh generation then is quite important because with those you would be able to apply these single equation to every single of these cubes that or box that we make. The mesh quality will impact the accuracy of result. If you go with a much more finer mesh, the result we get is quite close to the actual result we expect once we run it through the actual experiment. But again, it's time consuming. So, and on the other side, if you go with not really dense meshing and not accurate meshing, is faster. But again, the result you get might have a little bit difference with what the result you get. Usually the difference is around 10 to 20%. But of course, if you're the main aim, the main goal of the CFD, you want to get close to the 1 to 5% basically tolerance with the actual experiments that you do. You can see that here is a mesh generation for a different kind of models you have. You can see that actually we apply the local meshing to the area to make sure that result we get is accurate. But again, CFD has a pros and cons. On the good side of it, we're going to use a computer which they are really really cheap these days, to be honest, and we can get extensive details results from it. Also, it allow us to run the simulation on the final product with the real world physics to see how actually or predict how actually they will perform in reality. But also the another benefit is just the design optimization, which is really important. We can check the results, come back to it, update the design, amend the design, and then explore it again to see what was the impact of that changes. However, there is a lack of standardization. You cannot just say always that you have to go with this kind of route. So it depends on the geometry you have. You might need to do it differently, and that's the thing. Also, the other thing, there is so much misunderstanding, especially in terms of the result you get. There is so much misunderstanding on the interpretation of the basic result you get, and it's really important to make sure what you're doing and the result basically understand it and define it properly. Also, the other thing, CFD is an experimental analysis and there is no working backward. What it means is basically the CFD, you need to run that experiment. You cannot say that's my expectations and then that's the result and then come back to do the design. It's basically in the opposite direction, which basically you have a design, you test it, run the simulation, get the result, and if the result is not what you're looking for, then you will come back and update the design and then again run it. After a period of time, depends on experience you have, you might have some sort of expectation. For instance, if you I don't know, add a wing to the car, you can predict some sort of the down forces that you have at the back of the car. And again, it's time. Depends on the mesh quality you have. It might take a few minutes. It might take few hours or few months. In the today example, you can see these are really simple model where you go with the general mesh size. So it's around few minutes. But of course, again, for instance, if you want to run the CFD properly on the Airbus wing, might take a few months. Depends on how much computer power you have, and that's why in the CFD they use the cluster of powerful computers to make sure that actually they can reduce that time. And that's the other aspects of the cons of using the CFD. In terms of the CFD processes, we deal with three different stages. It's almost the same across all softwares. We always start from pre-processing, which basically define the computational domain. We need to prepare our geometry for these analyses and also discretize our model using the mesh generation. And then also on the solver side, we have to then decide what kind of solver we want to use, and that solver basically apply those equations that gonna run the simulations, define the boundary conditions, and run the simulation. And now that's the main part. You want to do a post-processing. You want to see the results and then analyze those results, because that's the main aim of the CFD. So that's quite an important stage that we need to work on. So great, that was just a brief introduction about the CFD. It's quite an important topic. If you're interested in that, make sure actually you spend some time to do your own research. It's a really big topic. I can talk hours and hours of that. I just touched the surface of the CFD and I didn't go to the details of it, especially on the equation side. And the main aim of today is to be able how we can apply a CFD and run the CFD analysis using the SolidWorks. So for the first experiment, what we're gonna do, we're gonna start with the laminar pipe flow, and we want to do a basically internal flow analysis. And what I want to do, I want to prepare my geometry to be able to apply that CFD analysis on it. So what I want to do, I'm gonna go to the SolidWorks, make sure the SolidWorks is open. I'm gonna create a new part file. You can use a Control N, or you can go and create a new file on top, and it's a part, and I'm gonna click on OK. So once the SolidWorks part has been created, what I want to do, I want to make sure first of all the unit that you're following is mmgs. So I'm gonna deal with the millimeter, gram, and second for this tutorial 1, and I want to pick up the right plane and create a new sketch in the right plane. And what I will do, I'm gonna create the 2 circles exactly on the center, and they want them to be concentric, have the same centers, and I'm gonna give them dimension to it. So the smaller one, I want to give the 16 millimeters diameter, and the bigger one as the 20 millimeter diameter. So once we apply the dimension, I'm gonna exit that sketch, and I want to extrude it. But because I want to extrude symmetrically, I'm gonna change the directions, and from the blind, I'm gonna use the mid plane, and let's extrude it for the 100 millimeter. And click on OK. And you can see that's basically the pipe that I created. So make sure we save it. I'm gonna do a Control and S, and I'm gonna go and save it in tutorial 1 and call it the pipe 01 for all T01 for tutorial 1. And now basically my model is ready. But in terms of applying the CFD, what I want to do, I want to define the inlet and outlet. And that's why it's really important to prepare my geometry for it. And in order to do that, I need to create the inlet and outlet while I'm here. So once I take it to the flow simulation, then I can use those. So what I want to do in here, I'm gonna pick up one side, let's say in here, click there. And now I want to create a new sketch on that face. And rather than I just go and draw circles on that, you already know that this is how I would be able to do it. What I want to do, I'm gonna just pick up or highlight the outer side of that cylinder, create on convert entities, and you will see that the circles would be copied using convert entities. And what I will then do, I click on exit sketch, and the circles that I generated using convert entities, I'm gonna click on extrude and extrude it just for 2 mil. And make sure the result is unmerged. I'm going to keep it as a different body, because then once I'm going to take it to the software, I can easily pick that one as an inlet and click on OK. And you can see this is what I created. I'm going to do the same things on the other part. So I want to highlight that face, create a new sketch, click on the outer side of the circle, click on the convert entities, make sure I exit the sketch, go to the features, click on extrude, and extrude for 2 mil, unmerge the result, and click OK. So what you will end up, you will see that the extrude you have here, one body, second body, and third body. Basically, this one is a main body. And also, if you want, you can actually rename these to make sure which one is inlet, which one is outlet. So let me call it inlet. That one, let me call it the outlet. And now what I'm gonna do, I'm gonna save it. So now I want to go and open the CFD side of the software, which we call it a flow simulation. In order to do that, you need to go and move on to the flow simulation. If in case you don't see this tab, which means that you don't have that add-in and you need to bring it. In order to do it, make sure you go and click on that gear icon and click on add-in. And make sure you tick the SolidWorks Flow Simulation. Depends on what version you have, whether it's 2018 or the latest one, 2020 version. Make sure you tick this one. And if in case every single time you want to load it, click on there as well to bring it on every time you load it. It takes a little bit longer to load the software, but of course you always have it. And click OK. What I've noticed, if you're using the Kingston University Apps Anywhere, sometimes once you tick it, the flow simulation wouldn't happen. That basically the software didn't go and load that. What you need to do, you need to come back here, click on add-in, make sure you untick it first, click OK, and come back and then tick it. This is how you can force that basically the Apps Anywhere to go and download that add-in, which is quite common, especially if it's for the first time you're going to do it on your machine virtually. So once you've done that, and once you see the flow simulation, click on the flow simulation in here. And we're going to use the flow simulation wizard. It's a really useful tool and basically helps you on every single stages that you need to follow. So I'm going to click on the wizard. Depends on the computer you have, might take longer for the wizard to be appear here. So the first thing what I need to do, I need to give a name to the project. I'm going to call it as a Laminar pipe flow analysis, and I'm gonna use the default configuration. I don't want to change anything, and I'm gonna click on next. And here I have to decide what kind of unit system I want to use. And you can see every single time I click on these, the units will then change. I'm gonna use the SI, which is the MKGS. And also every single of these, while you're in that unit, I can change it. For instance, if I want to change the pressure from Pascal to the bar, I can come here and change it to the bar, for instance. I'm going to keep it as the Pascal for this one. So everything's default and everything is based on the SI, and I haven't changed anything. So once you're happy with your units, you're going to click on next. And here you have to tell the software whether it's an internal flow analysis or is it external flow analysis. In this case, it's an internal flow that we want to work with. And also you would be able to apply the physical features. For instance, if you want to study the radiation, the gravity, rotations, you will be able to do it here. In this case, it's a really simple tutorial, so I don't want to apply any kind of physical features in here, and I'm gonna click on next. So once I went to the next page, I have to then specify what kind of fluids I have. So in this case, I have basically water inside. So I'm going to go to liquids and I will search for water. Once you click it, make sure you click on add, and you will see the water comes here as the default fluid that we have here. And then I have to talk about the flow types, whether it's a laminar flow, which basically is a nice and steady flow that we have, or whether it's a turbulent one, which basically the velocity goes up, the Reynolds number get high, and then you have the vortex, the turbulent vortices, and also this is how we apply the Navier-Stokes equation to it. I'm gonna let the software to see what's going on actually in here, and I'm gonna keep it as laminar turbulent. But if in case you want to simplify that and only study the laminar flow, you can do it in here, or is in turbulent only. I'm gonna go with the laminar and turbulent, and I'm gonna click on next. So here I would be able to actually apply the, for instance, the wall thermal condition if I want to give any kind of, let's say the type of the wall, whether it's adiabatic or not, the wall temperature and so on, as well as the roughness. In this case, I want to keep everything as default, as simple as it is, and I click on next. So in here, what you will see then, you will see that basically the pressures, the temperature, which basically in this case is a normal pressure, normal temperature, and of course the velocity. For this tutorial, let me go back and then update something here because I want to go and then give the temperature to the wall. So rather than it goes to the default, I'm gonna go there and let's say I'm gonna apply the wall temperature to make it a little bit nicer. And rather than the room's temperature in here, I'm gonna change these to, let's say, 450 Kelvin, and click next. But the rest is everything as default. So room temperature, room pressure, I don't change anything else. So the only thing I've changed was the applying the wall temperature for the wall conditions. Initial condition, I haven't changed anything, so everything is default, and I click on finish. So it depends on the geometry might take a little bit longer for the Visual Flow Simulation to be able to do it, but usually if you have a simple model, it would be a straightforward. Still, my model is trying to generate, and now you can see the computational domain. Because I put the inlet and outlet properly, the computational domain is great. In here, I don't need to modify that because the inlet and outlet, I didn't merge them together, and this is why I just got it perfectly. And for this one, I don't want to see the computational domain right now. So what I will do, I'm gonna come here and click on the hide. But basically, it's really important. Make sure that it covers the full model except the inlet and outlet. And once you've done that, now I'm gonna tell the software which one is inlet, what's the condition for it, and which one is outlet. In order to do that, you have to come and define them into the boundary condition level. So you can see the software tells us the name of the project, laminar pipe flow analysis, or whatever you name it, the computational domain, that's the next thing you have to do. I decided to use the automatic one. I don't want to change it, but if in case you're gonna come back and change it, you can come here, click on edit definition, and you can use these arrows to manually modify them, or you can give the dimension to here. You can see in one of the example, we're gonna go and modify this one. But in here, I'm gonna keep it as simple as possible. I'm gonna go with the default one that software decided for me, which is good. So now we're gonna go to the boundary conditions, come here, right click, and insert the boundary condition here. And now I need to specify to the software which area is the inlet. So what I want to do, I'm gonna go there, pick up that face, and right click, and go to the select other, because I don't want the outer, I want to see the inner side of it. I'm gonna pick the face, the inner face that I have as an inlet, and make sure the inlet mass flow is clicked, and I would be able to actually in here come and give the mass flow rate. Let's change it as a 0.001 is uniform. I don't want to change anything else, but if in case I want to give the temperatures or make the turbulence parameter, I can come and define them there. Everything, I'm gonna keep it as default. I just changed the mass flow rate, and I'm gonna click on OK. So you can see that's the inlet mass flow 1. If in case you want to rename it, you can come here, right click, go to the properties, and rename it in here. If in case you want to come back and modify that, you can right click, go to the edit definitions, and then see it in here as well. So that's the first one. Let me go and then basically create the new one and the outlet. So I'm gonna go there, right click, click on insert boundary condition, and make sure the face one is unselected because it automatically bring it from the previous one. I'm gonna go and pick up the other face, right click, select other. I'm gonna pick up the inner face, and from here, from the flow openings, I'm gonna go to the pressure openings, which basically as an outlet. I'm gonna pick up the environment pressure, and I don't change anything here. I'm gonna keep everything as default and see how the flow goes, and I'm gonna click on OK. In order to see what's going on actually inside the part, what I want to do, I'm gonna go and click on the section view, section it from the middle, and click OK. You can see here, this is how I define the inlet. You can see the arrows that shows that, also the outlet that you want to see what's going on from there. Once you do that, you want to then decide the goals. What do you want to actually study there? And then it is really useful tool because then I can control the simulation when it's trying to calculate it for me. And also it's really useful tool to make sure actually the calculations that I'm doing, the solver is doing properly. You can either have it or you can just skip that and go straight to the results. But again, I prefer to usually have something to be able to control it to make sure the result I get is correct. And you can see once the complexity of these tutorials will then increase and become much more advanced, this is a really useful tool to make sure actually it runs perfectly. In this case, I'm gonna go and create a surface goal. So what I can do, I can go to the goal, right click, and you can see I have access to the global goals, point, surface volume, which basically you're gonna control a volume, you're gonna control a point or the global, the whole model. I'm gonna go and click on the insert surface goal, and I'm gonna do it, let's say at the end here, and I'm gonna change it to select other. Let me go and pick up that one. And in here, what I'm gonna pick the temperature fluid. Let's have a look on the average. And you can see that you have control of every single parameters that basically you're looking for, that you can come here. They have the minimum, the average, the maximum, and so on. And I'm gonna click on OK. So you can see that the goals would then appear here. Discretization on mesh generation is quite important. The software automatically done it for me using the global mesh. In case I want to modify that, I can go right click, go to the edit definition, and you can see that the mesh is automatic. But if in case I want to change it, I can go to the manual and then change it manually. This one is really simple model, so I'm not that bothered with the mesh. I'm happy with whatever the software automatically generated for me. And now everything's ready. So I want to apply the solution to that and let the solver solve it for me. I will then go and click on the run. It's a new calculation on these machines. I'm going to use all cores. In here, this is really useful because technically, if you have a complex geometry, your computer become out of control and you cannot control it, and then it might take few minutes, few hours, or few days, few months. So I want us to see how many core you're gonna give it. In this case, really simple geometry. I'm gonna give all the computer power and to run the simulation for me. I'm gonna click on run. What you will see here, it try to check the geometry, prepare the geometry. You can see prepare the model, going through the mesh. Depends on the computer power. Sometimes it may takes longer, and you will see that the solver is finished because it was really straightforward. So while these process going on, I could have a look on here. For instance, I can go click on the insert goal plot and look at it to the, for instance, the temperature. You can see the temperature is rising here, for instance. And you can come back and modify every single of these. For instance, I can change the calculations, the calculation control option, because the solver is already done, is finished. I cannot have a control, but usually when it takes longer, you can see in other tutorials, then you will be able to come back and use some of these features, which we're going to talk about it later. This one was quite simple. So I just let it run, solver is done, and I'm going to click on close. So what you will see, the result at the beginning was unloaded. Now you will see something here that basically shows that you have the result. So click on the plus, and now it's basically you decide what kind of results you want to get. So let's say what I want to do, I'm gonna go and get a cut plot. From here, I'm gonna do right click on it, click on insert, and I'm happy with the front plane, so you can decide what plane you want to have. You can control it through this plane or every single of the planes you have from the model. I'm happy with the front plane. I'm happy with the contour display, to be honest. And let's say the pressure, for instance, in here. And I'm gonna click on OK. So you will see that the pressure there. If in case I want to see the animation on that, I can go there. I can click on play, and you can see the changes of it over there. Let me have a normal to view, so that would be easier for you to understand it. Let me see. That would be easier. If in case I want to modify that, I can either come here, go to the edit definitions, and let's say change the contour from the pressure to something else. Or what I can do, I can come here and click on there, and then let's change it to the temperature of the fluid and click OK, and see that it changes of temperature. Let me play that one again one more time to play the animation. You can see the changes of the temperature into the CFD. If I want to save this graph, what I can do, I can come here, go to save as, and you can see I can save it as a PNG, and I can control the size of the image, what I want to do with it, and what's the name of that. Also, you can have different cut plots. Let me go and create the another one. So this one, let's keep it as a temperature. I'm gonna create one more and have it for the, let's say, the pressure. You can control, for instance, the number of levels, and even you can see and apply the vectors, the isolines. Depends on what kind of analysis you want to do. It might be different. In here, this one is a contour is the best option, and the pressure and temperature, these are the one that we are looking for. And click it. Make sure if in case you want to move between those, let me stop this animation first. Move between those, you're gonna hide something and then go to the other one, because otherwise you will see both of them together. Also, you can rename them. So here is a pressure. Let me go there, go to the properties, and let's say this one is the cut plot pressure. So you can recognize them later. And this one, what was it? It was, let me double check. This one was temperature. So I'm gonna go and then change that one as the temperature. So you can see that this is how we'd be able to see them. Let me hide this one as well. and I'm gonna hide this one. And now I'm gonna go and let's say how we can get the flow trajectories. What I'm gonna do, I'm gonna go to the flow trajectories, insert, and let's say I'm gonna get pressure is good. Let's have a look at the pressure. I'm gonna keep everything as default. I'm gonna click on OK. Let me pick up the face, the front plane, and click OK. And you can see the flow trajectory. Let me play that one for you. And you can see that basically the pressure that we get, because here was an inlet and over there was an outlet. So you can see the flow trajectories. You can come back here, go to the definition. What you can do, you can change the number of points. You can change the type of them from the pipe. You can go and let's say the spheres, for instance, and you can control the width of it and whether it's a pressure or you want to see, I don't know, a temperature, for instance. And you will see that you will be able to see there. Let me play that one for you here as well. So depends on what kind of flow trajectories you want to get is different. And also, if in case you want to get the goal plots, you can go there to the goal plots, right click, insert, and depends on what goals you define there, you have access to it here. I can click on show. That basically shows the values of them for me. If I want, I can go and export it to the Excel, which is really useful tool, especially if you're writing the report. And it shows you the minimum, the maximum values, and you can see here the minimum, maximum values, and also whether the result was converging or not, and also the graph, as well as the data of it, the data of that graph, the number of iteration, the changes into the temperature. So that's a really useful tool, especially if you want to write a report, which is basically the aim of doing the CFD. And on the other side, let me go back to here. What I want to do, even I'm gonna say how we can generate the report automatically for me. I can go to the report, right click, and click on create a report. For this one, I have to have a template, and usually SOLIDWORKS has a good number of the templates here. Let me see which one it has. I'm gonna go for the flow simulation, click on OK, and let it to actually generate that file for me, which is a really useful file to have. Let me open the Word document. You can see that it's basically the flow simulation report that we generated for the model. It has the information on the environment, the basic computer that I used, the model that I've used, the computational domain, the simulation parameters that we use in there, the mesh sizes, the type of analyses, basically that we have the initial condition, the boundary conditions, and so on. So it has the minimum maximum table, which is really useful for the different parameter you're dealing with. And at the end, you can also write your own conclusion. It's fully editable. You can modify every single aspect of it, and it's a really useful tool to use. So let me close this one, and I know I stopped the report, and that's it. So once you finish, make sure you save it. You can do a Control S, you can click on save, and it will be saved on the same place you have. So the next time you open the file, you have flow simulation, you can go back to the modeling. In order to do that, make sure you go there, click, and then you can go to the modeling part. You can see the model here, and see now I'm to the modeling environment. I can go back to the flow simulation again, back and forth, which is really useful tool, and you still have the results there. So let me close this one, and I don't want to save the last part I've done, and that was the first tutorial that I've done. In the second tutorial, we're gonna work with the flow simulation again, but this time is with Convergent, Divergent, Nozzle. So again, I will start with the geometry. Let's create a geometry together, and I'm gonna create a new part. I'm gonna do a Control and N. It's a part again. Click on OK, and make sure again you're on the MMGS units. If in case you want to change it, you can always come here and change it. And I'm gonna start with the front plane. So I'm gonna go and pick up the front plane and create a new sketch in here. And let's say I'm gonna create a horizontal line, a vertical line there, and make sure it's vertical. And then I'm gonna continue and make a line in here, goes there, make sure it's pick it up correctly from me. Okay, and make a line from here to there, and from here to there. Okay, so this is something we've done. We have the vertical line and horizontal line, and now I'm gonna give the dimensions to it. So let's say this one are gonna be 30 millimeter. Here, let's change it to 7.5, and let's change this one to 2.5. And because this one is underdefined, you can see how I can control it. So let me bring it here, do it like that. And now I'm gonna give dimension to it to make sure I can control that one. So distance between those two, I'm gonna change it as the 1.25. And I'm gonna give the distance between that point to here as 10. So this is what we've done in here. I'm gonna click on OK to close the dimension dialog, exit the sketch, and now I'm gonna use the revolve to go revolve around here. So I'm gonna go to features, click on the revolve, and I'm gonna revolve it around that axis. And what I'm gonna do, I'm gonna click on OK, and you can see this is how I've made the revolve. In order to make it hollow, I could use the thin feature, but now I prefer to use a shell, to be honest. I click on shell, pick up this face, that face, and let's say the shell for the thickness of 0.5. Click OK, and you can see this is how I made the divergent, convergent divergent nozzle. And what I'm gonna do, I'm gonna save it. So let's say I'm gonna save it as the tutorial 2, as the convergent, or even let's call it the pipe tutorial 2. That's even better. Okay, so that's basically my model is done. But what I'm gonna do, I'm gonna prepare it again for that flow simulation. So I need to apply the inlet and outlet. Let's assume that the inlet gonna be the smaller piece, the outer side, the bigger side gonna be the outlet. So same as what I've done before, I'm gonna go and pick up that face, create a new sketch there, pick up the outer circle, convert entities, click on exit a sketch, go to the feature, extrude, and this time rather than 2 mil, because I have a really small model, I'm gonna put a 0.5 millimeter and make sure they are unmerged. Let me double check whether they are unmerged. Yeah, unmerged. And I'm gonna repeat the same things on the bigger side. Go there, create a new sketch on there, highlight the outer circle, convert entities. Okay, and exit the sketch, extrude of that bigger circle 0.5 millimeter, unmerge the result, and you can see like that. Even if in case you want to name it like before, you can come here and then put it as the inlet. You don't have to, but sometimes it's better to know what you're doing here. So let me go and put this one as outlet. Okay, so once I've done that, let me save it again one more time. So everything seems to be ready, and now what I can do, I can go and use the flow simulation. So I'm gonna move from the features tab to go to the flow simulation, and I'm gonna click on the wizard. So I'm gonna let the wizard to be opened. Let's name this project as the, I don't know, as Convergent Divergent Nozzle Flow Simulation. Quite a long name. And you can put the comments if in case you want to have. The configuration, I'm going to keep it as the default. Click next. So in here, I'm going to use again SI. But what I want to do, I want to change the pressure from the Pascal to bar, because the information I have is in bar. And let's even change the temperature from Kelvin. Let's change it to the Celsius. And click on next. Is the internal flow again. I don't have any physical features I want to add. The fluid I have here, the liquid, it's liquid and it's water. Click on add to make sure it comes there. And also in here is a laminar turbulent again. I don't change it. It's click next. And this time I don't want to decide or change anything for the wall condition. I'm going to keep everything as default. Click next. I don't change anything on thermodynamic parameter or velocity parameter. I'm going to keep everything as default and click on finish. So that's the software to create those computational domain for me. And you can see again, is perfect. The computational domain, I don't need to change it. For this model, to be honest, it's really simple, but of course you will see that we need to modify it once you go with a much more complex tutorial. So let me hide it again. And now I'm gonna go to the boundary conditions. I'm gonna define the inlet and outlets. So let's click on the insert the boundary conditions, and I'm gonna, again, like what I've done in tutorial 1, I'm gonna go there, right click, use the select other, go and pick up that face, and it's an inlet mass flow. Well, let's change it from the flow. Let's change it to the velocity, inlet velocity, because the information I have is a velocity. And let's change the velocity to the 50 meter per second. I'm also gonna give the temperature to the water. So I'm gonna go to the thermodynamic parameters and change the temperature from the room temperature. Let's change it to the 50 Celsius and click on OK. Now I'm gonna go and define the outlet. So I'm gonna go there, click on insert boundary conditions. Let me pick up the other side, select other, and it's gonna be that face, the interface. I'm gonna go to the pressure openings. Let's change it to the environment pressure. I don't change anything, everything. I'm gonna keep it as default, and I'm gonna click on OK. In order to see actually the inside of the model, I'm gonna go and click on the section view. Click on OK. I'm happy with it, and you can see that I have access to seeing the basically the inlet and then the outlet in here. And so what I can do, I can create a goal in here. For instance, let's say I'm gonna go and get I don't know, an pressure, for instance. Let's go and get it from the front plane. Let me see whether it actually, or what I can do. Let's go and check the pressure on the here. I'm gonna see the pressure on there, and let's go and see the total pressure average, which is fine to see what we are doing as an example. Mesh, I'm gonna keep it as default. I'm gonna go to the definitions and make sure that everything is automatic. I haven't changed anything here. And now what I want to do, I want to basically apply the solver on it. So what I'm gonna do, I'm gonna click on run, new calculation, use all the computer power, click on run, and let the solver try to solve it. You can see it start to prepare the model, mesh generation, going through the calculation, and it can get basically the graph, so you can see the pressure in here. So you have to be quick if in case you have a really simple simulation to get it, because once the simulation has been done, you cannot get those plots in here. So you can see the changes of the pressure. You can see the changes of the pressure here. I can come back and modify it. I can go, for instance, and then modify that. In one of the examples, we're gonna go there and modify these. And once everything has been done, what I'm gonna do, I'm gonna click on here to close this one down. You can see the result is appear here. And I'm gonna go and let's say I'm gonna get a cut plot. Let's see on the front plane, I'm gonna go and get the pressure. So you can see the changes of the pressure. Let me play that one for you as well if you want to see the changes of the pressure that we have. And let's get, for instance, the let's see. Let's get the velocity in X. Click OK. And let me hide this one and play that one. So it's a velocity that you will have over there. And let's have a look on the flow trajectories. Let me stop this one. I'm gonna go and get a flow trajectory. Let me hide that as well. Of course, if you keep it, the flow trajectory goes above it. But because I want to show it properly, I'm gonna hide this one. Get the flow trajectories. Let me insert it, and let's get it on this one, and then I apply it on the faces. I'm gonna have it as keep it as the, for instance, I don't know, its velocity seems to be fine. Let me go and pick up the front plane, click OK, and what I'm gonna do, I'm gonna click on play in here. And also what I can do, let me stop this one. I'm gonna hide that and get the flow trajectories, but this time I'm gonna pick up on the inlet and outlet. So let me go here, select other, let me pick up that one and change these as the velocity is okay. From the pipe, I'm gonna go with lines. Click OK. And now this is for that one. I'm gonna add the other part as well. Flow trajectories, insert. I'm gonna go and then pick that one up, select others, that one. Let's keep it as the lines. Velocity again, click OK. And now let me play these. So what you will then see, you will then see them. This is how basically the flow you will get, and also become the the turbulent at the end. So that's really nice one. Also, if you want to control the speed of that, you can always go there on the animation. You can control it there. Or what I usually do, you can go to here, edit definitions. That basically you can increase the number of points. Let me increase this one. Also, basically, you would be able to change that as well, the line width. I think, yeah, a little bit 4 seems to be okay. I'm happy with everything. I'm gonna click OK. And you can see the changes that we have on the flow trajectories. And same as before, I can use the goal plots to export these. So let's say the total pressure comes here. If I want to export it to the Excel, I can go and export it to the Excel, and you will see the result in here and the graph of it and the plot data, which are really useful. And let me go back in here, and then what also we can do, we can get the report as I mentioned earlier. And that's basically this one for the second tutorial. You can see it's straightforward, but it depends on those boundary conditions or what you want to get. Again, depends on, this is really general. I didn't specify, I didn't have any goal for this one. But again, if you have a special goal, you have to just go and then do the one that is important for you to do it. So that's this one. And now let's go and move on to the third tutorial. In tutorial 3, what we're gonna do, we're gonna go and work with the mixing fluids. That basically is the two different temperature of the water. They're gonna go and join together and see how it works. So let me create this a new model. Let me save this one and then create a new model. Create a new part, click on OK. And now here I use the MMGS. I'm gonna start with the front plane and create a new sketch there. And I'm gonna make the path first and then make a profile and then use the swap feature. So I'm gonna make a horizontal line, a vertical line. Let me give the dimensions before I give them the fillet, 150, and this one as 100. And now I'm gonna then apply a fillet to make the pipe nice. Fillet between those two, and let's say radius 50. Click OK. I'm gonna exit the sketch. And now what I want to do, I want to make a circle exactly on there. So this is not a 2D sketch. What I'm gonna do, I'm gonna go to the features, and sorry, to the sketch, and I'm gonna use the 3D sketch on the plane. And on the plane, I'm gonna pick up the right plane, and 3D sketch on the right plane. I'm gonna draw a circle there. And let's give the dimension to that for 25. millimeter as a diameter. And if you have a look, let me come out of the 3D sketch. Make sure you click on the 3D sketch on the plane again to come out of it. You can see I create a profile and using the 3D sketch. And now what I'm gonna do, I'm gonna go to the features, use the sweep boss, and I first needs to specify which one is profile. I'm gonna pick up that sketch as my profile, and then basically the path gonna be the sketch one. And in order to use the shell later, I'm gonna apply the tint feature right now to save some time. I'm gonna put it as a 1.5 millimeter in one direction. I'm gonna click OK, and you can see this is how I create a pipe in here. So that's the inlet, that's the outlet. But what I want to do, I want to have another inlet because I want the two fluids to mix together. So what I need to do, I need to create a new plane. And in order to do that, I'm gonna go to features, reference geometry, go click on plane, and let's create a new plane from top plane. And I'm gonna have it as the, let's say, get a distance from 50 mil. Let me have a look, but not there. I'm gonna use the flip because I'm gonna have it in here. I'm gonna click OK. So you can see this is where I got that plane, and I'm gonna have a sketch there. So what I want to do, I'm gonna go there and then create a new sketch. Let me go to the normal view to this one, and I'm gonna create basically two circles. Make sure you don't touch these circles because otherwise that basically the information you get is from those circles. What you can do in order to exactly be in the center of that, what you can do, you can basically go there and then try to be in the center. That's to make sure it's accurate. But otherwise, make sure you don't give any dimensions from the before, so you can see I don't want to have it like that. I'm gonna do it like this and then apply the dimension later. So is in the center of that circle we have. If not, you can go back and then give the dimension to it, which is 100. In this case, I already put in the center, so I don't need to leave that one. So let me give, if this more dimension let me to do that, yeah. I'm gonna give this one as 15 for diameter and that one as an 18. Exit the sketch. And what I'm gonna do, I'm gonna go to the extrude. Rather than using the blind for a direction, I'm gonna use the up to surface and pick up that. You can see the extruded wall through that one and make sure the result is merged and click OK. So you will see that it's good, but again, I no longer have the hole inside. So what I need to do, I need to go and cut it. So what I want to do in here, I want to basically go in here. Let me have a look. And now what I want to do, I'm gonna go and create a new sketch in here. Click on sketch, create a new sketch. But this time I'm gonna pick up the small circle, click on convert entities, exit the sketch, and now I'm gonna use features, extruded cuts. I'm gonna make it through all cuts to basically go and remove that area that it basically meet that face, and you can see now I do have a cut exactly over there. So I finished that one, and technically the model is ready. So I'm gonna save it as the let me put in a tutorial 3. I'm gonna call it pipe tutorial 3. And I'm gonna click on the save. So technically the model is now ready, but then again I have to modify. I still have to apply the inlet and outlet. So what I want to do in here, I'm gonna go and say these two are gonna be inlet. So first of all, let me get rid of that plane and hide it. So what I'm gonna do, same as what we've done before. So I'm gonna go to that plane, that face. Click on the sketch. It's basically create a new sketch. Click on the outer circle, convert entities, exit a sketch, features, extrude, and extrude it for 2 mil. Make sure it's unmerged. Usually I use a 2 mil for these models. And click OK. And you can see the first inlet. And second one, like before, I'm gonna pick up that one, create a new sketch, the bigger circle, convert entities, exit the sketch, go to the features, extrude it for 2 mil, unmerge, click OK. The same thing I'm going to do for outlet. Pick up this one, new sketch, big circle, convert entities, exit a sketch, feature, extrude, extrude 2 mil, don't merge, click OK. So the same as what we've done before. In order to make sure you name it properly to be able to recognize it later, let me call it the inlet 1. I'm gonna call it this one as the inlet 2. I'm gonna call that one as outlet, and I'm gonna save it. So technically the model now is ready, so I can go and apply the flow simulation to it. So what I'm gonna do, I'm gonna go to the flow simulation. I'm gonna click on wizard. Let the wizard to be open in here. And let's call it the mixing fluids simulation or flow simulation. It's a default configuration. I'm gonna click on next. SI unit I'm gonna use. I don't change anything here. It's the internal flow without any physical features in here. Click next. And let me bring the liquid. It's the water, but it's a two different temperature. I'm gonna click on water, click on add, and it's the laminar turbulence. Let's do it laminar this time, laminar only. Click on next. I don't change anything on the wall conditions. Everything's fine, everything as default, and I'm gonna click on finish. So you can see again the boundary, sorry, the computational domain that is created, it doesn't cover the inlet outlets extrude that I create, which is exactly what I was looking for. I'm gonna hide it again. I don't need it this time. It still is there, but it just hide it, right? And I'm gonna go to the boundary conditions, and let's say the one that has the bigger ending gonna be the hot water. So I'm gonna click there, select other. I'm gonna pick up this face. Inlet mass flow. Let's change the mass flow rate to the 0.005. Is uniform. I'm gonna change the temperature and make it as the 393 Kelvin, and click OK. And what I'm gonna do, I'm gonna go and basically do one more. So let me change this one so I can record inlet mass flow, or I can call it the, let's say, hot fluid inlet. I'm gonna go and create the other one. I'm gonna pick, let me make sure it's just the correct one, this face, and select other, the inner one, inlet mass flow again. So let's change the mass flow rate as the 0.001. I'm gonna go to the thermodynamic parameters, change the temperature. Let's keep it as a 293.2 at room. As you can see, it's cold water in here, cooler than the hot one that I just created. Let me go and change that to the cold fluid inlet. Click on OK. And now what I'm gonna do, I'm gonna make the outlet here. So for the outlet, I'm gonna go and pick this one up. Let me clear this one here, select others, that one. I'm gonna go to there, and let's change it to the total pressure. I'm gonna keep everything as default. I'm gonna click OK, and you can see total pressure, or if you want, you can call it as the outlet. So for then mesh, I'm gonna keep it as default. I don't want to change anything else. I'm gonna keep it as default. I don't modify anything. And also for the goals, let's go and create on, give me a second, what plane I have. If not, we can create one basically of the cross sections. Let me apply the cross section first. Yeah, that's a good cross section. And now I'm gonna go and based on that one, let me see whether, yeah, the front plane seems to be good. Let me see whether I can get it on the front plane. I'm gonna apply it on all the sides, and let's say I'm gonna check the temperature, the average temperature there. And of course, you can control the inlet, outlet. You can see inlet, inlet. If you zoom in, you can see the inlet, the inlets, and the outlets in here. And let's load it. Let's run it. New calculation. Use all the computer power, and I'm gonna let the wizard go and prepare the model, prepare the mesh, generate the mesh, and continue. So you can see that the changes of the temperature on the wall itself, and also you can see the basically the pressure that we got. Solver is finished. So what I'm gonna do, I'm gonna click on close here. So let me close this one down. And let's go and have a look to the results. So let's say I'm gonna create a cut plot, insert. Yeah, front plane seems to be good. Let's have a look on the pressure. Maybe do it as a this one is good. And you can see inlet, inlet, and that's the outlet. So if you want, I can play that, the changes of the pressure. If you want, you can check the changes in the temperature. So you will see the hot flow, the cold flow that we had there, and you can see that they will mix together, and the basically the temperature of the water will then change because they will mix together. Let me stop this one and then apply the flow trajectories. Insert it. Let's say I'm gonna keep it as a temperature. Let's go with the pipe first. For front plane again, click on OK, and let me hide cut plot. And now I'm gonna run this one. So you can see that I will have the hot flow rate, and also I have the cold flow rate, and they will mix together over there. Let's change this one and go and use the dynamic trajectories. I'm gonna change it to sphere. Click on OK, and now run it. So you can see this is become nicer. This is, you can see the flow that basically join together. Again, so all of these you can come back and modify them. This is the beauty of the software. Let's have it as an arrows. Click on OK, and now play it. We can see that the hot water and the cold water, they mix together. Same as before, if you want to get the plots, you can get it from the here, the gold plots, you can generate their pose. If any of these you want to save it, you can come here and save it. So let me save the full analysis, close this one down. And now we're gonna move on with the last tutorial, but the last tutorial gonna be the external flows. It's a little bit much more complex about what we've done so far, but it would be really fun to see how we can apply the CFD to see the aerodynamics of the car. So for tutorial 4, make sure you open the car assembly tutorial full file, that you can see that some part of the car has been assembled. We have the body, we have the wheels. But in order to prepare the geometry, now let's say we have the geometry, now we want to prepare the car. For the analysis we have, I need to make a road. So what I will now want to do, I'm gonna go and create a new file. Once we come here, make sure actually is we change the units from the mmgs to the mks, which is the meter kilogram in second. And now I'm gonna create a sketch on the top plane. Click on a sketch, and what I want to do, I want to use the midpoint line in here and make a vertical line. And now I'm gonna go and make a horizontal line here and a vertical line there. Make sure it meets there so I can make the rectangle. In terms of the dimension, I'm gonna give this one as the 25 meter, and the back of the bits of the rectangle are gonna have it as 8 because I use the midpoint is exactly in the center. Otherwise, if you didn't use midpoint, make sure you give the dimension from here to the 4 that basically comes that point to the middle. But in this case, it's because I use the midpoint, I don't need to give that dimension, otherwise I'll become overdefined. I'm gonna exit the sketch, and if you want to ask about how we come up with the length of it, basically we're gonna use this road and bring the car usually around 2 times of the car length in front and 4 to 5 times the car at the back. So 3.5 to 4.5 is usually the figure that we get at the back of the car. So now I'm gonna give the thickness to this one. So I'm gonna go and extrude a little bit, just a little bit. Let's extrude it for the let's say 0.02 meter, because what I want to do, I want to bring the computational domain a little bit inside the road to be able to run it properly. And now I'm gonna save it. Let's call it as the road T04 because I was doing that for the other day. Let's call it the road tutorial 4. Okay, and now what I'm gonna do, I'm gonna close this one, go back to the assembly that we have, and now I'm gonna bring that component here, insert the component. It's the road tutorial 4. Click on open. Let's just leave it there. Okay. And now I want to use the mates to make a relation between this one to bring the car into the exact position that I'm looking for, as well as to bring the car into the center of this road. So the first thing, I want the road to touch the wheels, or the wheels touch the road. So what I'm gonna do, I'm gonna go to mate, pick up that top plane, the top face of it, beat the top plane in here as a coincidence, so that it comes and the wheels you can see now is touching the road. And now what I'm gonna do, I'm gonna make the distance from the origin with the edge of the road, bring it a little back. So this is how we can control the location of the car. So let's say from the edge to the origin, I want to give the distance of 6. You can do it like that, or you can make the relation between this one and the front of the car as a 4 meter. If I go to the evaluate, let me comes out, you can see that from the edge to the front of the car is around the 4 meter. And now, in order to bring the car in the middle, so what I want to do, I'm gonna go and use the mate again. Let's say, let me see what plane I have. The front plane match with this front plane as a coincidence, and exactly the car comes to the middle of the road. You can see it like that. If I bring it like this, you can see that the car is actually touching the road, which is really good. So now let me save this one. It comes out and save, and basically my geometry now is ready to go and study the external flow on it. So what I'm gonna do, I'm gonna go and move on to the flow simulation. Click on wizard again. You're gonna let the wizard to be open. Let's call it the car aerodynamic simulation. And I'm gonna keep all the configuration as default. I'm gonna move on. Let's make sure it's SI, and I don't change any of parameter. Click on next. Here, make sure is external rather than internal, and make sure you exclude internal spaces because you don't want the actual flow goes inside the car. External, exclude internal space. Click on next. I don't want to change any physical feature here. The fluid we have is gas and is air this time. So I'm gonna pick the air, click on add. You can see it comes here. And basically what we have, we're gonna keep it as the turbulent only this time, because the air that we have, we want to basically simulate that how once the car getting a speed, how the air gonna interact with the body of the car. and click on next. And in here for the wall, make sure is the adiabatic roughness is 0. So I don't change it here. It's just the adiabatic and also roughness is 0. Click on next. Initial condition, so I'm gonna keep the thermodynamic parameters the same, but I'm gonna give the speed to it here for the velocity as a 70 mile per hour, or let's say 31.293 in here, and click on finish. And you can see now his model is ready to actually work with it. So you can see car aerodynamic simulation here. The computational domain is not what I'm looking for in this case. So I want to modify that. In order to do it, I can go and click on edit definition, and you can use these arrows to modify it. So you can see that whenever I move these arrows, basically I can modify that. So let me go and have a normal to, so what I usually do, I go and manually bring it there, make sure it's cover the road, because if it's become bigger than the road, basically you will have the turbulent vertices on the side because it's out of the computational domain. And here, let me go and pick up that one. I'm gonna bring here to there as well, and okay. So you will see something like that. You have the road, but in order to become exactly correct, I already have the numbers for it. So please go click on edit definition and modify that. So maximum and minimum x. The minimum x gonna be 6 meters. So you can see it's quite close to what I've already done manually, but this time is with a calculation to make sure it's correct. And the minimum, sorry, the minimum is 6, maximum is 31. You can see again it's quite close to what I've done. The minimum y is minus 0.02 because I want to go a little bit inside the road to make sure the result will get it's accurate. Maximum is 5. Z minimum is minus 4 to 4. And click OK. So this is based on how we usually do this analysis. Great. And now I've defined a computational domain. Now I'm going to go to the boundary conditions. Let me go to the boundary conditions, insert the boundary condition, and now I'm going to pick up the face of that road in here. And I'm going to move from the flow opening, go to the wall, pick up the real wall. I'm going to apply the 0 basically micrometer for the roughness of it. And I'm going to give motion to the wall because I want to actually move with the car. So I'm going to give the same basically speed, which was 70 mile per hour, or 31.293 meter per second to match with the speed of the car. And so that's this one. And now basically everything I've done here, that's fine. And now what I'm gonna do, I'm gonna go and apply the mesh. So in here, we can go with the default one. And what I recommended, your own time, run it with default as it is. Don't change anything and run and see the results. And then come back and modify the mesh. I want to tell you that the result is different. I don't want to actually waste your time to do it right now, but it's really important to do it at your own time. At the beginning, go with 1, and then go and then start with the 1, and then increase it to the 7. And you will find out in here that 3 is good, but again, let's change the minimum gap size. I'm gonna apply it as the 0.1. We're gonna get quite close to the car. Ratio factor, I'm gonna keep it as it is. I'm gonna click OK. But of course, if I increase it to 7, it may take much more longer, and the result you get, it's quite accurate. Because in order I want to run the simulation straight away, I'm gonna keep it as 3, but I'm gonna make the close contact with the body of the car. And let's create a few goals. I'm gonna create the surface goals, and let's say in here I'm gonna get the surface goal on all of the car. But because it's only the surface, what I recommend, go here, go to the view. From the view, go to the toolbar, and from the toolbar, bring the selection filter. And for the selection filter, I'm gonna pick up the filter faces because I want to just pick up the face of the car, not the inside of the car. I'm gonna pick up the car, wheels, wheel 1, wheel 2, wheel 3, wheel 4, and what I'm gonna do, I'm gonna pick up the force X, on that, and also I think that's okay. I'm gonna click on OK in here. So I'm gonna pick up the force Y average as well in here, and let me see whether everything was fine. So let me scroll down. Yeah, everything's fine, and I'm gonna click on OK. So something was important. I used the filters to be able to do it. So what you will see then, we have the force X, we have the force Y in here, and we already applied the mesh, we modified the mesh as well. And so basically, let me go back with the no filter. I don't need any filter in here. I'm happy with everything. So I'm gonna just run the simulation, click on the run. Something I want to mention, if in case you want to control the basic running, so whatever we've done so far was by default. If you want to control that, what you can do, you can come here, go to the calculation control option. You can do it right now, or you can do it once they actually you run that simulations, and you will be able to see few things here. So you can say that basically the goals that you want to have to converge, yes, I'm happy with it. And also you will be able to go to the goal criteria, for instance. And the goal criteria right now, it doesn't have anything there. But what I can do, I can change it. Let's say I'm gonna get it to the manual. 1 Newton is good, and manual 1 Newton in here. What it does, it continues until the changes in the total X or the Y force per each iteration is become less than 1 Newton. So you keep going. The number of iteration would then increase up to the time I get there, which basically the result from none will then change. This is when the software gonna stop basically. And you can go on, you can do the other refinements, you can apply even the, for instance, you can apply the scale factors here and so on. So that's a really useful tool to be able to control it, where to start, or what kind of, how many iteration you want to have. Even you can control the calculation time, the number of iteration, for instance, you can control it. Rather than 100, you go with a few thousand if it wants to have much more accurate. But I'm gonna just control basically the forces. And once you reach there, I think the result I get, that will be fine for me. So I'm gonna click on OK, and now I'm gonna run it. New calculation, use all the computer power, run. And you will see that it's trying to prepare the model, apply the mesh. Again, if you're doing it for the first time, it might take longer. For this one, because I already done that before, it would be a little bit faster. And you can see this is the graph that we get. So what I've done in here, so by default, there is no minimum maximum. So by default is like that. So let me show it to you. So it's like this. And this is not what I was looking to do. So what I've done here, I came there and then apply the minimum maximum. So for minimum, I keep it as the minus 200, and the maximum, I put it as the 1000. And also I changed the length scale from 10 to 2.5. That one will give you a better graph in here. And so let's leave it on there. And also it here's for the velocity, you usually don't see the car because the plane that we have is not exactly in the middle. So what do you need to do? You need to go to the properties, make sure in front plane, and move it to the 0.8 according to the model that we have, to make sure it comes exactly in the middle of the car. By default, what you see is like this. So don't panic if you don't see the car properly. Go to the properties and then change it as a 0.8 here. And you will see it like that. The same thing if you come here to the properties, you can see I change it from the top plane to the 0.5 to be able to see that and why the analysis is going. So it's really useful to actually see basically what it does. And as I mentioned also in the calculation, if you notice, calculation control option, I changed the goals criteria in here. Even if I want, I can come back and update it in here. If I want, I can pause the simulation, or I can stop it and come back to it later on while it's processing, because as I mentioned, it might take a few days or few months to do it. So these are really powerful tools. You can actually work a bit. Then you can see the number of the cells for the mesh that has been created, and you can see the mesh generations. It still is trying to apply, do the calculation, and you will see at the end you will get to how many iterations that you will end up having with. So right now we are in iteration number 40. Great, so I'm gonna give it some sort of time to go through that basically simulation, and then I gonna come back to you once it's been finished. So these are, we see them because basically we already defined that into the goal. But if in case you don't see it, what you can do, you can come here, click on the insert preview. Based on whatever I've defined over there, I can put it as the different planes. The offset, I can go to the setting, I can say what do you want, I get the pressure, velocity, whatever, and the size of it, and whether you want to save the video of it or even display mesh. Let's say I'm gonna display the mesh, and you will see that, for instance, the mesh in here. Let me change this one for, and let's change it to the velocity X. I'm gonna show it what's the difference in here. Velocity X, and then if I remember it was a 0.8. Oh no, this one was a 0.5. And you can see, for instance, that's the difference we have between those two, and this is how actually this model is being created. Same for this one, and that's the front plane from here. So now we can see has been finished for me with my machine with a 16 gig RAM and i7. It took me 10 minutes to run. So it might take longer for you, might be quite faster. So you can see this is the graph I got. Every single of these, as I mentioned, you can actually save it as well, which is really useful. So for me it's finished, and what I'm gonna do, I'm gonna close this one. So once the simulation has been finished, let's have a look at about the results we got. So rather than I create a cut plot, this time I create a surface plot. Let me show the first one. And because I wanted to see actually what's the kind of pressure I have on the surface of the car. So what I've done, I created and inserted a new surface plot. And in order to be able to bring the faces, like what I've done before, I went to the view and toolbars, selection filter, and I pick up this one, the filter face, and pick up the faces from the car, and all these four wheels is a contour, a pressure, and the number of levels is 10. I haven't changed anything else, and I click OK, and this is what you will see here. For the second plot, I wanted to get the total pressure. Let me show it to you in here. The total pressure is the same as what we've done there, but the only difference what I've done here is basically if in case you don't see the total pressure into the contours, make sure you scroll down, go to the add parameter, and go to the loads and tick the total pressure. And this is how you can see the total pressure will then appear here. And again, the number of level of it is 10 by default, and you can see the pressure. So I can understand what sort of what area of the car, what face of the car I do have a pressure, so I can come up with a better proposed alteration. So let's have a look at about the flow trajectories. Let me show the first one, for instance, that I created. And it's a really useful graph for the velocity in the X direction. So in order to see how I generated it, of course, I went to the flow trajectory, click on insert, and a few things are modified here. First, I want to get it from the right plane, so I pick up the right plane, but I got that offset because I want to get the distance from that plane, and I use the 3.5. 13.5 is basically bring it, you can see that exactly on the back of the car, so I can see basically what's going on with that kind of vertices at the end. Also, I changed the number of points to 60. It's lines. Also, I changed the line width to the 2, and the rest is as default. And also, as I mentioned earlier, is the velocity X. Let's have a look about this one. And let me play that. You can see this is a really useful basic analysis to find actually what's going on the back of the car and how I'd be able to basically predict that. You can see that also. You can see that all the forces in here that I will be able to get it through the velocity. So let me hide this one. I'm gonna go with the second flow trajectories that I've done. It's the right plane, same things, every the same definitions, the same offset from the right plane, the number of points, but this time is the total pressure. So let me run this one as well for you, so you can see it in here as well, the total pressure that we have. And of course, if you want to see it better, usually what I will do, I will use a Control 8 to see it on that side, to just see what's actually going on in here. So also I've added the surface parameters there. So the same things. What I've done, I pick up all these part of the assembly except the road, but it's just the faces. So I use the filter. And now let's say density, mass flow, pressures. So I take the majority of things, areas. And now I want to go and let's say click on show to use these numbers. So these are really useful numbers. You can actually put in your analysis. I also put these for you so you can have a look. Of course, if I want to export it to the Excel, I can do that. You can export it to the Excel and you can see it will generate an Excel file for you, which is really useful because usually you're looking for these kind of parameters to understand it, understand the car and the aerodynamics of the car. You can see it in here. Let me close this one down. And so on. You can create your own goal plots if you want. If you want, you can generate the reports in here. And that's basically, this is how you would be able to run the aerodynamics on the car. And it's a really useful, especially if you're dealing with the external flow. Great. So thank you so much for your time. That was it for today. And that was our last session for the CAD CAE Bootcamp. And thank you so much for everyone who attended. We started from the 2D modeling. We went through the 3D modeling techniques using the features. And then we went through the assembly. We went to the technical drawings. We went through the FEAs. And also we went through the CFD. We tried with both software. With the Siemens NX we started, which is much more the industrial one. Then also we went through the SolidWorks, which is much more suitable for the startups, small, medium companies, and the educational purposes, and prepare you for even the other software if you want to work in industry with, such as the CATIA and even Siemens NX, which is basically an industrial software. Thank you so much for staying with me during these 9 weeks, and hope these sessions were useful for you for your projects. And take care and see you next time.